same permission. Well, technically, there's nothing to prevent other applications from say, I also require that permission. But what you can do when you're defining that permission is say, well, not only is this a unique permission, but I don't want you to grant this permission to any other application unless they're signed with the same key as me. You can also implement that kind of restriction on broadcasters. Broadcasters, like the intent system, is a way for applications to send messages to each other, except it's only about state changes. So an application may say, I received a new RSS feed and send a broadcast intent to every other application because there are other applications that may want to consume that RSS feed. Well, you can restrict who you're going to receive broadcast messages from if you don't want other applications to mess with how your application performs given a state change in another application. Content providers are a kind of specialized activity that are just for exposing databases to other activities and applications. And they have a second level of permissions that you can implement, giving other activities only read access, only write access, or giving them read and write access. Although, as already been noted, if you have write access to a database, given enough persistence at specialized write requests that you make, you can effectively read information out of it. And so just be aware that setting write-only permissions doesn't necessarily mean that other applications won't be able to glean access they could read out of your database. So persistent storage in Android. Unlike Blackberry, Android actually can use the standard Java I/O calls. So I'm not going to be talking about security issues there that are already well known. But there are some unique facilities that Android provides as far as persistent storage goes, especially as regards preferences that are being saved. There's a shared preferences class that will allow you to share preferences just for your components and not for applications. If you have, at the activity level I was talking about, if you have a specific activity that wants to remember some information, you can save that information just for that activity, and no other activity will be able to have access to it. Another thing to keep in note is that with the open file input and open file output calls, those calls are restricted to the application's root directory exclusively. So if you have information, perhaps you're doing file-based information where the user's providing input, and you don't want to bother with making sure there's no directory traversal going on, you can use those calls that will automatically throw exceptions if there's any kind of traversal characters in it, because they're designed only to use the root directory, no subdirectories, no parent directories whatsoever. SQLite is a bit different than Blackberry. You don't have the kind of encryption options that Blackberry provides. You don't have any option of making it available to other people natively except through the content providers. So it's restricted just to your application alone. Excuse me. But like I said, you can use content providers between applications to share that kind of information out. So there's some miscellaneous issues that I thought I'd talk about here. There are the native applications you're developing for Android, and there's also the concept of widgets. These are applications that are running on the home screen rather than a separate application. So something to keep in mind if you're developing widget applications is that since widgets are actually hosted as part of the home screen process and not their own process, that they're inheriting the permissions of the home screen process. And those permissions are generally much more than what the specific application may have defined as being required for them. So as the saying goes, with great power comes great responsibility. So making sure that with the new permissions you have, that you're resistant to attackers trying to coerce you to use permissions that you otherwise hadn't intended to use in the first place. Along the same lines, the Bluetooth admin permission will enable your application to automatically turn Bluetooth on or off without any kind of prompting to the user. Normally, applications that define Bluetooth privileges have that privilege, but the user is still warned, hey, this application wants to turn on Bluetooth. Do you want to allow this? With the Bluetooth admin permission, that's not going to happen. And finally, there are a couple of ways to get pictures on the Android platform. You can either implement the camera class if you have the camera permission to use it, or you can just send an intent to the native camera application and get camera data from it. The camera application by default injects EXIF information into it, which may include location data. So you may want to be careful to give your user the option of scrubbing that information out of it. Or if you're calling the class that doesn't automatically inject that information, tell the user, I didn't put any EXIF data in here, would you like me to? And then proceed as they wish. So moving on to Windows Phone. Windows Phone 7 still in beta, so they haven't sold any phones yet, but I'm sure they're hoping to sell a few. I don't have one to test with, of course, so all of this is based on my use of the emulation environment. It's hard to say how many applications are out there, given that technically you may consider some pre-existing Silverlight 3 or 4 applications as being Windows Phone 7 applications, because Windows Phone 7 is based on Silverlight. The environment that they have there is kind of a hybrid between Silverlight 3 and Silverlight 4, with even more changes to make things more confusing for you. It also supports the XNA environment, which is used widely for developing Xbox Live games, but I'm not going to be talking about that here because it's primarily gamer focused. They released the CTP in April, the beta in July, and maybe they'll have a final in October. An interesting thing here is that with the release of Visual Studio 2010, it is technically not possible for you to develop Windows Mobile 6.5 applications anymore. You have to retain your older versions of Visual Studio because Microsoft just isn't going to support it anymore. So isolated storage in Windows Phone. Since it's all based on Silverlight, it's using Silverlight Sandbox. Oh, excuse me. All right. So Silverlight Sandbox uses the same kind of principle everyone else does, which is you have your directory, you can write to that directory, you can do all sorts of damage into that directory, but if you try and reach outside of it, you're going to get stopped. Let me rewind a bit. Most of you may know Silverlight as a browser plugin, but one of the more recently introduced features is the ability to run Silverlight controls outside of the browser. And outside of the browser, these Silverlight applications have desktop quotas that limit how much information they can store in their isolated storage. In the typical environment, they get a 1 megabyte default quota, but they could ask the user if they need more, and the user could give them more if they really wanted to. In the Windows Phone environment, quotas don't exist anymore because the assumption is that every application is running outside of the browser. The concept of a quota doesn't make a whole lot of sense. That's not inherently a bad thing, except if you're putting an application from a pre-existing Silverlight environment into the Windows Phone 7 environment, and you're counting on that quota enforcement to limit the amount of damage that could be done. On the desktop, a file-based DOS on your application can't do much damage if you've only got a 1 megabyte of space. But in the Windows Phone 7 environment, if a user or application is able to use up all of your storage, users are going to get very unhappy very quickly and just automatically remove your application. So if making sure that when you're doing persistent storage on Windows Phone 7 that you're keeping mind of how much you're using. And just as a final note, since all of the applications of Windows Phone 7 are running out of the browser, there's no concept of having a site origination. When Silverlight applications are running in the browser context, there's a specialized isolated storage that allows Silverlight applications that all originate from the same site to establish an isolated storage that they can share between. Since there's no sites in Windows Phone 7, there's no more site storage, so you don't have any kind of isolated storage. You could share data between applications. So capabilities in Windows Phone, it's akin to Android's permission system as far as defining can this application access the internet, can this application access the camera, but that's pretty much where it stops. It doesn't have the same facility, for example, saying that particular methods can only be accessed under certain conditions. In the Windows Phone 7 environment, if you're creating a new application, the default is that you automatically request all of those permissions. If you're not aware of that, your application may be requesting a whole lot more permissions than you need, and those may eventually be abused down the line. Unlike for Android templates where no permissions are requested by default, and it's up to you to incrementally request them. In the Android system, it's known that for any particular permissions your application is requesting, the user is presented with a pop-up saying this application is requesting these permissions, do you want to grant them? I don't know whether the same kind of system will be in place for Windows Phone 7. All I know is from using the emulator environment, I know the emulator environment doesn't much care what permissions I'm requesting. So there's some miscellaneous issues for Windows Phone 7. The largest one, of course, given the hybrid nature of the Silverlight environment and the unique changes that they've made for Silverlight Mobile, is that documentation, good documentation, is really hard to come by. depending on methods that you're implementing, they may not behave the way that they're documented. And so that's something that a real rigorous QA process is going to have to shake out if you're already developing Windows Phone 7 applications. Many methods that operate just fine in the environment still may return slightly different values in Silverlight Mobile. For example, let me see, I made a note here. I think it was a get path directory will return an empty string if the path happens to have any leading white space in it for some reason. There was another, I think it was, there was another call I don't remember the name of that wouldn't throw any kind of exception even if the path name was too long for the maximum path size. Another thing to keep in mind is that many applications, if they still throw exceptions under conditions that they ought to, may be throwing different types of exceptions. And so the handlers you have set up to handle the exceptions that you expect may not be the exceptions that are being thrown anymore. So again, a real rigorous QA process is going to shake those out. As a final note, DTD parsing is completely taken out of Silverlight Mobile. There are some valid security concerns there, given the ability to force the application to request DTDs over and over again. But rather than providing the facilities they have in other versions of Silverlight where you can use it at your own risk under certain circumstances, being careful to catch exceptions, they've simply taken it all out. And so in the event you're developing an application where you have to use DTD parsing instead of switching to XML schemas or something, you're going to be forced to write your own. And we've seen more often than not when folks are forced to write their own implementations of commonly available API functions, that it's going to wind up a lot more insecure than if they just had the native facilities available to them. So moving on to the iPhone. They have sold over 8 million phones, which I think makes them the second largest. But they have the most registered apps, over 200,000 apps available in the App Store. And that's not even counting the applications that are available for folks who have jailbroken their phone. The iPhone environment is primarily Objective-C 2.1 based, kind of, which we'll get into later. iOS 4.0 was released just this month. And they've been doing major software and hardware releases just about every year. So memory management in the iPhone. The iPhone is unique compared to the other platforms I've been talking about before because all the applications are on managed code. You're responsible for allocating your memory, you're responsible for deallocating your memory, and unlike the Objective-C runtime on Mac OS X, you don't have any garbage collector to help you out with that. So all of the standard memory management and memory corruption issues that you're used to in unmanaged code on C and C++ are present on the iPhone, so I'm not going to spend a lot of time there. Just be aware that they're there, and you should make sure that you're taking care of those issues. An interesting thing to note for folks who aren't familiar with Objective-C is that you have the ability to release an object or auto-release an object. And auto-releasing is really just a nice way of saying, well, I'm not really sure if I need this object again, so let's put it in a pool, and I'll empty that pool when I'm really sure I don't need it anymore. So if you auto-release an object, it's still leaking until you drain that pool. So if you're using auto-release at all, make sure you're draining your pool in a timely manner. Otherwise, you might as well just be using release when you're absolutely sure. An interesting thing to note about preference storage for the iPhone is that as far as violating the sandbox concept, you have two options for saving preferences. You can do preferences all your own in your application, in your own sandbox, and do very complex settings. Or if your settings are of a more simplistic nature where you have a slider, a few fields, and that's it, you can implement a settings bundle that actually be installed as part of the settings application and run in that sandbox. Depending on the simplistic needs of your preferences, you could go either way, but one thing you might want to consider is given the attacking value of compromising a sandbox where every other application may be saving its preferences versus just your sandbox where you're saving your preferences. Each application is going to have different acceptable risk levels, but it's something to keep in mind that you have that choice. Mac OS X developers who are used to being able to share preferences between applications are used to be able to define suite-based preferences in a separate storage area where all of those applications can read and write from. Because of the sandbox nature of the iPhone, suite-based preferences just aren't supported.